Hi, this is Talkboard, and I want to teach you about rates of change. So a rate of change, I think the best way to think about it is it's the gradient of a tangent or the gradient of a line that joins 2 points on a curve. So to demonstrate how to find the rate of change of a particular curve, I've got an example. It's f of x is equal to 3 log e x. And I'm going to graph that just to the right so we can see how a rate of change works graphically. F of x, x, there is an asymptote at x equals 0, and the log curve looks like that. This point here is 1, 0. So I might ask, what is the instantaneous rate of change at x equals 1? And notice I'm using the word instantaneous, which means just at that particular point. So all we have to do is go to the curve, find the point I'm looking for, which is 1, 0, and draw a tangent to that point. The gradient of that line is the instantaneous rate of change at the point. So the way we find the gradient of a tangent is we take the derivative function. F dash of x is d fx over dx, which is equal to 3 times 1 on x from here, which is equal to 3 on x. So the instantaneous rate of change at x equals 1 is equal to f dash 1 is equal to 3 over 1 is equal to 3. So this yellow line over here has a gradient of 3, and that is the rate of change. A question they might ask relating to this is they might say, find the x value where the instantaneous rate of change is equal to, we'll say here, 1/2. So remember, the word instantaneous is related to the word tangent, because that's what we're looking for. So we're looking for a point on this blue curve over here where the gradient is equal to 1/2. So here it's equal to 3. Behind it, that should be steeper back here, that should be 9 or 10. And further in front, that's when we start to see the gradient decreasing, potentially towards 1/2. But notice it'll never go below 0 because we'll never have a negative gradient sloping downwards. The most we'll get is limit x approaches infinity is a gradient of 0, a horizontal line. So we're thinking the point is going to be somewhere along here, that we're going to find an instantaneous rate of change or a tangent with a gradient of 1/2. So the way we solve this is we say, okay, the gradient, f dash x, has to equal 1/2. F dash of x is equal to 3 on x. So therefore 3 on x has to equal 1/2. Therefore x is equal to 3 divided by 1 on 2, 6. So 1, not to scale, we might put a point here, 6, and then 3 log e 6. The gradient at this point, the gradient of the tangent at that point is equal to 1/2. So the answer is x is equal to 6. Now, average rates of change are a little different. I'll try and shift this over. Average rates of change. And what you do here is join 2 points with a line. Notice it's not a tangent. And then the gradient of the line is equal to the average rate of change between those 2 points. So a question might be, what is the average rate of change between x is equal to 1 and x is equal to e? E being a constant, so e would be somewhere here. We'd have e and then 3 log e, which is 3. So they're saying these two specific points here and here, if we join them with a line, join them with a line, what is the gradient of that line? Now the gradient of the line is equal to rise over the run. So first of all, let's find the rise. Rise is equal to the height of this point up here, which is equal to Fe. Take away the height of this point here, which is equal to F1. So that becomes 3 log E, take 3 log E1. That's equal to 3 times 1 equals to 3. That is the height here. And the run is equal to the difference between this point and this point along the x-axis, which is equal to E take 1. Therefore, the gradient of that line is equal to rise over run, and that's equal to 3 over E take 1, which on my calculator comes out to 3 over 1.71 approximately, which is actually equal to 1.74. Move this question over. Similarly, in the first example I did to the very left, when we were discussing instantaneous rates of change, it was asked, find the point where the instantaneous rate of change was a half. A question that could be asked in relation to average rates of change is find the value x. Actually, we'll say find the value a, such that the average rate of change between x equals 1 and x equals a is 1. So we set up our formula again. We've got some value a along here, and it's got this coordinate a, 3 log e, a. So the difference in height between this point and this point up here is equal to fa, take f1, and since f1 is 0, this is just simply equal to fa. And the run is equal to a, take away 1. Because there's a, there's 1, and this distance here is a take 1. Therefore, the gradient is equal to fa over a take 1, which is equal to 3 log e a over a take 1. And we're saying this gradient has to be equal to 1. Therefore, it equals 1. You can solve this with your CAS calculator. It comes out as a is equal to 6.71. And that is instantaneous and average rates of change.